In our interconnected world where digital trust is essential and transparency matters more than ever, a transformative technology has emerged that's changing how we think about record keeping and verification. Blockchain. It's a revolutionary system that goes far beyond being just the foundation for digital currencies. In this video, we'll break down this sophisticated technology into easy-to-understand concepts. Whether you're a technology newcomer, an aspiring investor, or a business professional looking to stay ahead, this video will give you a comprehensive grasp of blockchain technology, what it is, why it matters, how it functions, its various forms, and where it's headed. Let's dive in. What is a blockchain? In simple terms, imagine you're keeping score in a neighborhood sports league. Traditionally, one person keeps the scorebook, and everyone has to trust that they're recording things accurately. But what if that person makes a mistake or decides to cheat? Now, imagine instead that everyone in the neighborhood has an identical copy of the scorebook, and every time a game happens, everyone updates their copy. If someone tries to fake a score, everyone else's books would show the truth. That's the core concept of blockchain. At its most basic level, a blockchain is like a shared record book that's distributed among many participants. Anyone in the network can add new records, but once a record is written, it becomes permanent and unchangeable. These records are visible to all participants, creating complete transparency. This record book isn't kept in one central location like a bank vault or a single server. Instead, it's copied and synchronized across thousands of computers worldwide, making it truly distributed. Let's use another example. Imagine you and your roommates share household expenses. To track who paid for what, you create a shared spreadsheet that everyone can access. When someone buys groceries, they log it with the date, amount, and their name. Everyone can see these entries and they're timestamped, so no one can go back and change history. If someone claims they paid the electric bill when they didn't, everyone else can check the shared record. That's essentially how a blockchain operates. In the digital realm, this shared record system could serve countless purposes, from tracking financial transfers like cryptocurrency payments, to recording ownership of assets like real estate, to managing contracts, to verifying supply chain movements, or even recording votes in elections. The entries could represent anything valuable: currency, property titles, medical records, or digital art. So in straightforward terms, a blockchain is a permanent, transparent, distributed digital ledger that logs transactions across numerous computers. It's a system designed to establish trust, ensure accountability, and provide security in an increasingly digital world where these qualities are paramount. What is the main purpose of a blockchain? The primary purpose of a blockchain is to facilitate secure, transparent, and immutable record keeping in a decentralized environment. It's fundamentally about building trust between parties who don't necessarily know or trust each other. Let's explore this further. Security. In a blockchain, every entry is encrypted and connected to the one before it. This chain of entries is accessible to all network participants, but modifying any single entry would require altering every subsequent entry across thousands of computers simultaneously, something that's virtually impossible. This architecture makes the blockchain highly resistant to fraud and unauthorized changes. Transparency. Every entry on the blockchain is viewable by all network members. This openness creates accountability and makes it extremely difficult for anyone to manipulate the system. Everyone can verify everything. Decentralization. Traditional databases are controlled by central authorities like financial institutions or government agencies. A blockchain, however, is spread across numerous independent computers called nodes. This distributed nature means no single authority has total control, making the system resistant to censorship and eliminating vulnerable central points of failure. At its core, the fundamental purpose of a blockchain is to create a secure and transparent mechanism for parties who may not trust each other to reach consensus on shared information without requiring a trusted middleman. Whether it's transferring digital currencies like Bitcoin, registering land ownership, or monitoring products through manufacturing and shipping, blockchain's purpose is to enable secure, transparent, and streamlined record keeping. What can a blockchain really do? Blockchain technology, though frequently linked to digital currencies, has numerous practical applications that can impact regular people in meaningful ways. Here's what blockchain can genuinely accomplish. blockchain enables direct peer-to-peer transfers without intermediaries like traditional banks, which could result in quicker transfers with reduced costs, particularly valuable for international money transfers or supporting family members abroad. It can also create visibility throughout production and distribution networks, meaning shoppers can confirm product authenticity, trace items from origin to shelf, and make informed ethical buying choices. Beyond commerce, blockchain can offer a secure method for managing digital identities, streamlining online identity verification and making it simpler and more secure to access services like digital banking, online shopping, or governmental platforms. The technology could also enable secure, transparent electoral systems, minimizing fraud risks and facilitating remote voting, potentially boosting participation rates. In healthcare, blockchain could create secure, interconnected medical records that give patients greater control over their healthcare information and could enhance care quality through better data sharing. For creative professionals and artists, blockchain provides a way to register and safeguard intellectual property, ensuring proper compensation for their creations. Additionally, blockchain powers decentralized finance, or DeFi, which seeks to replicate conventional financial services like lending or insurance in a decentralized, transparent way. This could extend financial services to populations currently lacking access to traditional banking. As you can see, the applications are vast and varied. As blockchain technology matures, the uses for this remarkable innovation will only expand and diversify. How blockchain works. Understanding blockchain mechanics might seem daunting, but let's simplify it into clear, sequential steps. The process begins with transaction initiation, where a user starts a transaction. This might be transferring cryptocurrency like Bitcoin to someone else, recording an agreement, or submitting a ballot in an election. Once initiated, the transaction requires verification. In a blockchain network, verification happens through a network of computers called nodes. These nodes validate the transaction details, including authenticity and participant credentials. After verification, the transaction joins other verified transactions in a block. Each block has limited capacity, and when full, a new block begins. Before joining the chain, the block receives a unique identifier called a cryptographic hash. This hash is generated from the block's transaction data and is completely unique. The block also includes the previous block's hash, creating a connection between blocks, hence the name blockchain. The block now joins the chain, but network nodes must first agree the block is legitimate. This happens through consensus processes. In blockchains like Bitcoin, this is mining, where nodes solve complex mathematical challenges. Other blockchains employ different consensus methods like proof of stake. Once consensus is achieved, the block joins the chain and the transaction concludes. The blockchain updates and all network participants can view the new block and its transactions. Can a blockchain be hacked? While blockchain technology is engineered for security and tamper resistance, it's not completely invulnerable to attacks. However, successfully compromising a blockchain is exceptionally difficult and demands substantial resources. One potential weakness is the 51% attack. This happens when one entity controls over half the network's computing power, enabling them to manipulate new block recording and verification. They could potentially double spend coins, using the same digital currency twice, or block other miners from validating transactions. However, executing a 51% attack on major established blockchains like Bitcoin would require massive computational resources and is therefore extremely improbable. Another vulnerability exists in smart contracts running on certain blockchains. If smart contract code contains bugs, hackers might exploit them. This occurred in the notorious DAO hack on the Ethereum blockchain in 2016. It's crucial to understand that while the blockchain itself may be secure, applications and digital wallets interacting with the blockchain can be vulnerable. Many reported blockchain breaches are actually compromises of these peripheral systems, not the core blockchain technology. The different types of blockchains. Blockchain technology has developed into several distinct varieties, each with unique characteristics and applications. Here are the 4 primary blockchain types. Public blockchains are accessible to anyone wanting to participate. They're decentralized and transparent, meaning anyone can join, validate transactions, and create blocks. Bitcoin and Ethereum exemplify public blockchains. Their main strengths are robust security and transparency, though they can be slower and demand more computing power due to consensus requirements. Private blockchains, on the other hand, restrict access to authorized members designated by network administrators. Businesses often use them internally, offering greater control over who validates transactions and creates blocks. This control enables faster processing and reduced computational demands, though with some sacrifice of decentralization. Hyperledger Fabric is an example of a private blockchain platform. Consortium blockchains, also called federated blockchains, are governed by multiple organizations rather than one. They balance public blockchain openness with private blockchain control. The banking industry often uses them where multiple financial institutions might share a blockchain. Hybrid blockchains merge aspects of public and private blockchains. They allow control over information visibility and access, while still enabling verification through a decentralized network. DragonChain exemplifies a hybrid blockchain. Each blockchain type offers distinct advantages and trade-offs, and choosing between them depends on the particular requirements and objectives of the users or organizations involved. The future of blockchains and their true potential. The future of blockchain looks both exciting and contentious. This technology's potential reaches far beyond current uses and is positioned to transform traditional systems in ways we might not fully grasp yet. Envision an internet independent of tech corporation control, where data privacy is standard, not exceptional. Blockchain could establish the groundwork for a decentralized internet, or Web 3.0, where users own their data and digital identities. This could fundamentally alter digital world power structures, though it raises questions about governance and oversight in a truly decentralized internet. As blockchain and cryptocurrencies advance, we might witness a global token economy's emergence. In this economy, tokens representing physical assets like property, artwork, or even personal time could trade on blockchain platforms. This could democratize investment access and create a more inclusive global economy. However, it could also disrupt established financial systems and necessitate new regulatory approaches. The intersection of blockchain and artificial intelligence could produce more transparent, efficient, and secure AI systems. Blockchain could maintain a tamper-proof record of AI decisions, crucial in areas like self-driving vehicles or medical care. But it also raises ethical concerns about AI control and use in decentralized contexts. Controversially, quantum computing's emergence could threaten blockchain. Quantum computers might potentially crack the cryptographic algorithms securing blockchains, triggering a quantum apocalypse. However, this also accelerates quantum-resistant blockchain and cryptographic technique development. In conclusion, blockchain's future is an exciting journey into unexplored territory. It promises a more decentralized, transparent, and equitable world, but also presents novel challenges and controversies. As we explore this new frontier, it's essential to maintain dialogue about the ethical, legal, and societal implications of this revolutionary technology. If you found this video helpful, please like and subscribe to stay updated on more technology breakdowns. Don't forget to hit the notification bell so you never miss our latest content. Thanks for watching.